Okay, ratio tables. The date is the 26th. Ratio tables. With ratio tables, we're going to have two vocabulary words. And yes, the first one is going to be ratio tables. So, ratio table is a table with columns filled with pairs of numbers that have the same ratio. So, this week and last week, when we've been talking about rates and ratios, when we're simplifying ratios, they end up being the same ratio, they're just simplified. When we have a unit rate, it ends up being the same as the original ratio, just in a simplest form of 1. One of our examples in our notes was 2 triangles to every 6 circles. And we simplified it to 1 triangle for 3 circles. Those are the same ratio, because every time you have 1 triangle, you're going to have 3 circles. When you have 2 triangles, you're going to have 6 circles. So it keeps going and going and going. Okay? Our second word is scaling. And scaling is to multiply or divide 2 related quantities by the same number. So when we simplify, we're actually scaling. When we simplify a ratio, we are scaling it by dividing both the numbers, if they look like a fraction, be the top number and bottom number, we're dividing by the same thing, right? That is scaling. You can also multiply to scale as well. So here's an example of a ratio table. It has 2 items, soda and juice. Those are the 2 things being compared. And the first table has the ratio of 1 to 3. So 1 soda for every 3 juices. Then it goes to 2 sodas would give you 6 juices. And then 3 sodas would give you 9 juices. Now the reason that this is a ratio table is because as we are moving these sodas up, multiplying by 2, but to get to the next one, to go from the first one to the third one, we multiplied by 3. So 1 to 2 is times 2. 1 to 3 is times 3. We did the same on the bottom. The juice went from the first box to the second box by multiplying by 2. And then from the first box to the third box by multiplying by 3. So these are equivalent ratios because they can all be simplified to 1/3. They can all start with 1 over 3, and the ratio stays the same for all of them. Are we ready? All right, let's make a ratio table. Okay, I'm going to give a problem up here, and you don't need to copy this problem down into your notes. I'm going to tell you what to write down. But for the sake of our information, we need a problem to go off of. And that says a recipe requires 6 drops of yellow food coloring with 1 cup of icing. So for every 6 drops of food coloring, we're going to have 1 cup of icing. How much yellow food coloring is needed for 5 cups of icing? So what I want you to write down is this rate. This is our starting rate of 6 drops for 1 cup. So the rate is, I want you to write down 6 drops to 1 cup. And now we can start our ratio table. And that's to make a table with the first ratio they gave us. They gave us drops of yellow food coloring and cups of icing, which is 6 to 1. So here's our table. Make sure you leave room on your paper after you write down 6 and 1, because we're going to end up writing some more columns on here. But to start with, we're just going to put in the information they gave us. Write down number 1. I want you to write down rate, 6 drops to 1 cup. And then I want you to write down number 1, make a table with the first ratio. And then draw the table. Yes, draw the table. Step 2 is we're going to add a column with the known quantity. So don't redraw this table. I just want you to add 2 more boxes to the one you already drew. So write down the direction, which is to add a column with the known quantity. And once you've got those 2 boxes, we're going to fill in the known quantity, which means the next part of the ratio that they gave us. So we know the original rate is 6 drops of yellow food coloring to 1 cup of icing. Now they gave us the next part, which is cups of icing. How many cups of icing did they give us? 5. So we can fill in that known part in order to solve for the missing part. And many of you are already seeing what the answer is, but we are filling out a chart right now, so you got to do it my way. Okay. And now the last part, the hardest part, is to solve for the unknown quantity by multiplying or by dividing. So, we know we had 1 cup of icing, and we know we're going to go to 5 cups of icing, which means we have to figure out how to go from 1 to 5. What do we need to do to the number 1 to get it to equal 5? Mason? Multiply it by 5. So if I multiply 1 times 5, I'm going to get that 5 cups of icing. And just like with simplifying fractions, simplifying ratios, equivalent fractions, whatever I do to the bottom number, I have to do to the top number. So if I multiply the bottom by 1, I have to multiply the other number, not by 1, sorry, by 5. So to get my final answer, I'm just going to complete this problem of 6 times 5, and that's going to give me 30 drops of food coloring with 5 cups of icing. And this is a very simple ratio table, but it looks kind of like equivalent fractions, doesn't it? How would you go from 1 to 5? Times 5, do the same to the top. 6 times 5 is 30, 30 over 5, or in this case, 30 drops of food coloring for every 5 cups of icing. All right. I need you to write down 66 hot dogs over 12 minutes. And you need to copy my chart. 66 hot dogs in 12 minutes. And then copy the chart down and put the numbers that are there. Okay? And this is a rate for a hot dog eating competition. We actually looked up in second period how much the world record was, and last year the winner of the hot dog eating competition, and yes, this is a real competition, ate 72 hot dogs in 10 minutes. So that person ate more than this record that's up here for our math. 10. This ratio is 66 hot dogs in 12 minutes. If you are already kind of like, that's gross, 66 hot dogs in 12 minutes, let's gross you out some more. Does anyone know how they eat hot dogs in the hot dog competition? They dip them in water so that the buns aren't all dry and they don't dry out their mouth, and they can just swallow the bread part easier. So not only do you have to eat a cold hot dog, but you have to have a soggy, wet bun too. Prize money, I don't know how much. Last year, the prize for winning was $40,000. $40,000 for the winner last year. There you go. All right, let's take a look at our table. We have 66 hot dogs in 12 minutes. Our ultimate goal is to get to how many hot dogs in 2 minutes. But we don't just want an answer here. We are working in a ratio table, which means we're going to fill out something in that middle box too. Okay? And usually when you have empty boxes, you'll have at least one number of the ratio. For example, the last box here has a 2 and above it is the blank one. So usually you'll have at least one number. In this box, we're missing both numbers. So we're going to have to come up with our own equivalent ratio. We are going down. We're getting smaller, right? We're starting with 66 over 12. We're going smaller to end up eventually at a 2. To make numbers smaller, do we multiply or divide? We divide. So we're going to divide here, and we are going to divide that 66 and that 2 by a common factor. And if you remember back in fraction days, I told you, if you don't see common factors or you don't make your list of factors, if both numbers are even, you can automatically divide by 2. So we have a 66 and a 12. Let's divide them by 2 because that's an easy number that we know goes into both of those. So we're going to take that 66, we're going to divide by 2, and we're going to get 33. And remember, whatever we do to the top number, we have to do the exact same thing to the bottom. So that 12 needs to be divided by 2 as well. So now we end up with 33 hot dogs in 6 minutes. The ratio is still the same. If I gave this person 6 minutes, they could eat 33 hot dogs. If I gave them twice as long, they'd eat twice as many. 66 in 12 minutes. All right, so we could go from our original ratio of 12 and get it to a 2, but we have smaller numbers here in the middle. Let's use those. Let's go from 33 hot dogs in 6 minutes and get to that 2-minute mark. So we're going to do that by going from 6 to 2. We're looking at minutes here because the end number we have is minutes. So we're going to go from 6 minutes to 2 minutes. And to get from 6 to 2, you would divide by how many? Yeah. This math problem is 6 divided by 3 equals 2. And because you had to divide by 3 on the bottom, you have to. The top has to be the same thing. So we're going to take 33, we're going to divide it by 3, and we're going to end up with our final answer, which is how many hot dogs this person can eat in 2 minutes? 11. All of these are equivalent ratios. Can you go from 12 to 2? What would you divide by? 6. Divide 66 by 6. What would you get? So these are all equivalent ratios. We're just going to multiply or divide the top and the bottom by the same number. They're worth the same amount. If I only gave this person 2 minutes, they could eat 11 hot dogs. If I gave them 3 times as much time, if I gave them 6 minutes, they could eat 3 times as many hot dogs, 33. The ratio stays the same. Okay? Yes? I made these. Yes, I did. They're nice and that's because these are more interesting than what we used to do, right? They're a little more pleasing to the eye. All right. So we've done some ratio tables, right? Now we're going to do ratio tables with that other vocab word called scaling, okay? And the reason we need to do scaling is because sometimes you can't just multiply to get the number you want, or you can't just divide to get the number you want. For example, in this problem, you need to write down the rate of 10 cans over $4, and then you need to copy down my chart. In this problem, we know that for every 10 cans, we have to pay $4. The rate of the cans is 10 cans for $4. The question is asking, how much for 15 cans? Now, take a look at this table. We have 10 cans, and we need to get to 15 cans, which means we have to figure out how do you get from 10 to 15. How do we go from 10 cans to 15 cans? All right, so we want 15 cans. What can I do to 10 to get to 15? What can I multiply or divide 10 by to get to 15? Yeah, I'm hearing silence. You know why? Because there isn't anything. Okay? So when we scale, we might have to go backwards. If our numbers are going up from 10 to 15, that would be going up. We might have to go backwards, and we might have to get a smaller number. In other words, we might have to divide first. Okay? So how do we know what to divide by? Well, we need a number in between, not in between, but the number to go in this middle box that works with a 10 and works with 15. In other words, we need a common factor. So if we list the factors of 10, 1, 2, 5, and 10. All right. The factors of 15. 1, 3, 5, and 15. So with this list, what's the greatest common factor between 10 and 15? 5, which means if I can turn the cans into 5 cans, if I can go from 10 to 5, that means I can go from 5 cans to 15 cans. Because 10 can't get to 15, but we can turn a 10 into 5 cans. How do I go from 10 cans to 5 cans? We're going to divide by 2. Okay, so now we've got 5 cans. Now we're not done here because we got to keep the money with it, right? This is a ratio. Whatever we do with cans, we have to do with money. So the top was divided by 2, which means the bottom is also. And 4 divided by 2 is 2. All right. So I can't, like the other table, I could go from the first ratio to the last ratio. I can't in this one. 10 doesn't go to 15. But now I have a new ratio that is equivalent. It's worth the same amount. 5 cans for $2. If I bought 10 cans, it would cost me $4. Now I can take that 5 over 2 and I can figure out 15. How do I go from 5 to 15? I'm going to multiply by 3. So if we multiply the top by 3, what are we going to do to the 2 on the bottom? Multiply by 3, and we're going to get 2 times 3 equals 6. Meaning the cost of 15 cans is $6. Now I want you to look at 5 over 2. Look at 5 over 2. Is 5 over 2 in simplest form? We made this ratio of 5 to 2. We started with 10 over 4, and we made this ratio of 5 over 2. Is it in simplest form? Yes, it is, because we found the greatest common factor and divided. That's how you simplify any fraction, any ratio, any rate, is you find the greatest common factor and divide. We found the greatest common factor. It was 5. We divided. We got the fraction of, originally, 10 over 4, and we turned it into its simplest form, which we have been doing for a couple days now. Simplifying ratios, it's the same as simplifying fractions. We found its simplest form. Once it's in its simplest form, then you can find any other number that is equivalent on your ratio chart. You can, but that wasn't the goal. The goal was to find out how much it cost for 15 cans. If you simplified 15 over 6, what would you get? 15 over 6 in its simplest form is 5 over 2. So if you cannot find an equivalent ratio, you need to put that ratio in its simplest form. Once it's in its simplest form, then you can find any other ratio on your chart. Yes. Only if you can't go like from 10 to 15. If this said 20, we can go from 10 to 20, can't we? Just multiply by 2. But you cannot go from 10 to 15, so you have to simplify the ratio and then figure out what to multiply by. Okay? We'll do another one. Another one with scaling. I need you to write this down. The rate is 14 hours to mow 8 lawns. And then I need you to copy this chart down. You should have this chart written down with 14 hours to mow 8 lawns. And the question says, how many lawns in 49 hours? Okay, so what we are doing here is asking you to figure out how many lawns this person can mow in 49 hours. We're going from 14 hours to 49 hours. can you go from 14 to 49? Can 14 multiply by anything and get to 49? And if you're not sure because you don't know your multiplication tables, pick a number you think might work and we can try it. Can you go from 14 to 49? Exactly. Okay, if you doubled it, it'd be 28. And then if you did 28 plus 28 or 28 times 2, it's going to be 56. Too much, right? So we can't go from 14 to 49. There's no number to multiply 14 by to get to 49, which means we're going to have to scale back and then scale forward. So you need to put 14 over 8, write this down, 14 over 8 in simplest form. Write that in your notes. And now we're actually going to simplify 14 over 8. Factors of 14 are 1, 2, 7, and 14. Factors of 8 are 1, 2, 4, and 8. What's the greatest common factor of 14 and 8? 2. So what we're going to do is we're going to take this 14 over 8 and we're going to divide by 2. Okay, so we're going to put it in simplest form. 14 divided by 2 is going to give you 7. And we have to do the same to the bottom, right? So 8 divided by 2 also, which is going to give you 4. So you can't go from 14 to 49, but now that we're in simplest form, 7 can go to 49 because 7 is a factor of 49, isn't it? So how do you go from 7 to 49? What do I need to do to 7 to get to 49? Yeah, multiply by 7. So 7 times 7 is 49, which means I have to do the same to the bottom. We'll take that 4 and multiply it by 7. And this is going to give me my actual answer I want, which is how many lawns this person can mow in 49 hours. And that would be 4 times 7, which is 28. So once we add the simplest form, then we can find any equivalent ratio. In this case, it was how many lawns in 49 hours. Okay? So when you're scaling, you might have to move backwards and simplify your ratio in order to then multiply and move forward. Okay? I want you all to get out your Chromebooks